right, thank you, Victor, and a very, very special thanks to Sumit and Clem for joining us today and talking about our partnership. No question, the software ecosystem is so important for enabling our hardware to be deployed more broadly. I would say it's a journey, and we know it's a journey, but we've made a tremendous amount of progress over the past year with ROCm and the most important frameworks like PyTorch, TensorFlow, and Onyx, and also really expanding our collaborations with key model developers and distributors like Hugging Face and many of the other open source models out there. Now, we always like to save hardware for last, so turning to AI hardware, let me say, the generative AI and large language models have changed the landscape, okay? The need for more compute is growing exponentially, whether you're talking about training or frankly, whether you're talking about inference. Larger models give you better accuracy, and there's a tremendous amount of experimentation and development that's coming across in the industry, and you heard that from both Sumit and Clem. At the center of this are GPUs. GPUs are enabling generative AI. So now let me turn to our Instinct GPU roadmap. CDNA is the underlying architecture for our Instinct accelerators. It's designed specifically for AI and HPC workloads. CDNA 3 is our brand new architecture that uses a new compute engine, the latest data formats, 5 and 6 nanometer process technology, and the most advanced chiplet packaging technologies. At CES earlier this year, we previewed MI300A. It's the world's first data center APU. And what we have is our CDNA 3 GPU architecture with 24 high-performance Zen 4 CPU cores. Now, these are the exact same cores in our leadership general processors that I talked about earlier in the show. And we also add with that 128 gigabytes of HBM3 memory, all in a single package. And what we have is unified memory across the CPU and GPU, which is frankly very effective, particularly for some HPC workloads. Now, this results in 8 times more performance and 5 times better efficiency compared to the MI250X accelerator that is in the largest supercomputers today. Now, MI300A has also been designed into supercomputers already, and it's slated for the 2+ exaflop El Capitan system at Lawrence Livermore National Labs. It's the most complex chip we've ever built, with more than 146 billion transistors across 13 chiplets. Now, you guys know we've led the industry with the use of chiplets in our products. And our use of chiplets in this product is actually very, very strategic. We created a family of products. So in addition to the MI300A product, with our triplet construction, we can actually replace the 3 Zen 4 CPU chiplets with 2 additional CDNA 3 chiplets to create a GPU-only version of MI300, optimized for large language models and AI. We call this MI300X. Now, for MI300X, to address the larger memory requirements of large language models, we actually added an additional 64 gigabytes of HBM3 memory. So with that, Drew, I am super excited to show you, for the very first time, MI300X. Now, for those of you who are paying attention, you might see it looks very, very similar to MI300A, because basically we took 3 chiplets off and put 2 chiplets on, and we stacked more HBM3 memory. But what you see with MI300X is we truly designed this product for generative AI. It combines CDNA 3 with an industry-leading 192 gigabytes of HBM3 that delivers 5.2 terabytes per second of memory bandwidth, and it has 153 billion transistors across 12 5 nanometer and 6 nanometer chiplets. So I love this chip, by the way. We love this chip. So look, when you look at the world, there are many things that you need. You need great compute engines, but you also need a lot of memory for everything that's going on. So when you compare MI300X to the competition, MI300X offers 2.4 times more memory and 1.6 times more memory bandwidth. And with all of that additional memory capacity, we actually have an advantage for large language models because we can run larger models directly in memory. And what that does is for the largest models, it actually reduces the number of GPUs you need, significantly speeding up the performance, especially for inference, as well as reducing total cost of ownership. So, of course, I want to show you the chip in action for the very first time. So let's watch MI300 in action, shall we? For this demo, we wanted to show you a large language model running real-time inference on a single GPU. And since we had Hugging Face here with us, we're actually going to run the recently released Falcon 40B foundational large language model, which is currently the most popular model on Hugging Face right now, featuring 40 billion parameters. So let's watch, for the first time ever, MI300X running Falcon on a single GPU accelerator. All right, let's start. We have to give the model a prompt. So we are here in San Francisco. Let's say, write a poem about San Francisco. Here we go, the poem's coming. You can see it's responding in real time. I'm not a great poet, I don't know about you guys. The city of dreams that always keeps you yearning for more. I would say that poem's pretty good, huh? Now look, you guys have all used generative AI already, and you've seen a number of generative AI demos in the past few months. But what I want to emphasize that's special about this demo is it's the first time a large language model of this size can be run entirely in memory on a single GPU. We've run a number of even larger models, including Meta's 66 billion OPT model, as well as the 65 billion Llama models. And if you just look using FP16 inferencing, a single MI300X can run models up to approximately 80 billion parameters. So what does this actually mean? If you look at the industry today, you often see that, first of all, the model sizes are getting much larger, and you actually need multiple GPUs to run the latest large language models. With MI300X, you can reduce the number of GPUs for this, and as model sizes continue growing, this will become even more important. So with more memory bandwidth, and fewer GPUs needed, what this means for cloud providers as well as enterprise users is we can run more inference jobs per GPU than we could before. And what that enables is for us to deploy MI300X at scale to power next-gen LLMs with lower total cost of ownership, really making the technology much, much more accessible to the broader ecosystem. And what that also means is that not only do we believe that we have better total cost of ownership, but we've also been able to significantly reduce the amount of development time needed to deploy MI300X. Our goal with MI300X is to make it as easy to deploy as possible. And what that means is the infrastructure is also incredibly important, which is why I'm also excited to announce the AMD Instinct platform. And what we're doing with this platform is, again, we're all about open infrastructure. So what we're putting is 8 MI300Xs in the industry standard OCP infrastructure. And for customers, what that means is they can use all of this AI compute capability and memory of MI300X in an industry standard platform that drops right into their existing infrastructure with actually very minimal changes. And with this leveraging of OCP platform specification, we're actually accelerating customers' time to market and reducing overall development costs while making it really easy to deploy MI300X into their existing AI rack and server infrastructure. So to sum it up, let me give you a few key takeaways. First of all, we're incredibly excited about AI. We see AI everywhere in our portfolio. With MI300X, what we offer is leadership TCO for AI workloads. We're really, really focused on making it easy for our customers and partners to deploy. So that Instinct platform really lowers the barriers for adoption. And frankly, the enterprise-ready software stack, we know that this is so important. We've made tremendous progress through our work with the frameworks and the models with our partners. And there's going to be a lot more that's going on over the next many years in this area. Now let me talk about availability. So I'm happy to say that MI300A began sampling to our lead HPC and AI customers earlier this quarter, and we're on track to begin sampling MI300X and the 8-GPU Instinct platform beginning in the third quarter. And in addition, we expect both of these products to ramp in production in the fourth quarter of this year. So I really look forward to sharing more details on the MI300 family when we launch later this year. Let me wrap things up for today. We showed you a tremendous amount of new data center and AI technologies, from our expanded portfolio of leadership EPYC server processors with Genoa, Bergamo, and Genoa X, to our industry-leading DPUs and SmartNICs, to our expanding AI software ecosystem, and our next generation MI300X data center AI accelerators. It is just an incredible pace of innovation, truly exciting. But what's more than that, we really appreciate the partnership with our partners, and a very, very special thank you to our partners who are here with us today: AWS, Meta, Microsoft, Citadel, PyTorch, and Hugging Face. We truly believe in co-development, co-innovation, and partnership. It's been a great day as we take another major step forward to make AMD the data center and AI partner of choice. Thank you so much for joining us.